Hi everybody, this is Ms. Bufford and this is video 2 in our thermochemistry unit, and in this video we're going to talk about thermal energy transfer. So your learning goals for this video are to be able to give real-world examples of conduction, convection, and radiation, and to understand how heat flows through a system. So I want to begin this discussion on thermal energy transfer by talking about how temperature and thermal energy are related. But before I do, I'm going to explain the use of the word system in these videos. When I use this word, I'm just referring to any finite amount of substance. I could be referring to anything like a chemical reaction or something else that we assume is kind of isolated. All right, so let's go ahead and get back to talking about thermal energy and temperature. So thermal energy is the energy that's given off by particles in a system that contain kinetic energy. So everything has a certain amount of thermal energy because everything contains kinetic energy or particles that are in motion. But the temperature is a measure of the average amount of kinetic energy that those particles in that system contain. And the more kinetic energy that a system's particles have, the higher the temperature is going to be. So it's important to understand how thermal energy moves through a system. Thermal energy is always transferred from areas of high temperature to areas of low temperature. And when thermal energy flows, we call this heat. The flow of thermal energy will continue until all areas of that system contain equal amounts of thermal energy. And at this point, they've reached the equilibrium and have the same temperature. So if we take a look over here, we've got some blocks. The red represents hot and the blue represents a colder substance or a colder block. If we were to push these two blocks together like they are right here in the middle, then you'll notice that the red starts to become less red and the blue starts to become more red. And what that's showing is that thermal energy from the red block is flowing into the colder block until they reach this equilibrium temperature where they're both the same temperature. They both contain the same amount of kinetic energy, or their particles do. Okay, so the main takeaways here are that cold does not move. Thermal energy moves through substances. If something feels cold, it's because it lacks some amount of thermal energy. And a system always wants to be at equilibrium. So thermal energy is always going to flow until equilibrium is achieved. So we're going to talk about 3 different modes of thermal energy transfer. We're going to talk about conduction, convection, and radiation. Conduction is heat transfer that occurs via microscopic collisions between particles in a system. This means that thermal energy causes these particles in a substance to vibrate. So let's take a look at this picture up here with the pan. It's kind of a sliced in half pan. And we take a look at the little magnified portion of that pan, we can see the particles. And the red particles, again, they represent the hotter substance, and the blue particles represents the cooler part of the pan. And notice how the red particles look like they've got a lot of kinetic energy. They're vibrating a lot. And when they vibrate so much, they kind of bump into the particles next to them and transfer some of that energy to the colder particles. And you can see how, as they gain more and more kinetic energy from the vibrations from the atoms or particles next to them, they're going to start to heat up and gain more kinetic energy, and it's just going to kind of work its way all the way across the pan until the whole pan is hot, okay? And it's the same with this metal rod down here that this person is holding in the fire. Thermal energy is kind of creeping up there slowly via particle collisions until the whole rod is hot and that person burns their hand. And it's the same if you have pots and pans at home that you cook with that have metal handles. They tend to get hot and you need something to hold that pan with or you burn your hand. So your pan is heating via conduction. Okay, so the next one we're going to talk about is convection. And convection is heat transfer that occurs in a fluid or gas via the current that is produced by the difference in thermal energy from one area to the other. And particle collisions are still a big part of how this energy transfer occurs, but the main thing here is that there's a current that's produced. And so I know you guys have all heard that hot air rises. And so we take a look at the picture of the house down here. I think this is the easiest one to understand at first. We've got this fireplace right here, and there's a bunch of fire in there. It's heating up this room. But what happens is that the hot air is going to be rising to the ceiling, and as it rises to the ceiling and moves away from that fireplace, it's going to begin to cool again. And once it becomes cool, it's going to kind of fall back down to the ground because it's more dense. Cooler air has a higher density than hot air, because remember we learned in the gas laws that when a gas heats up, it gains kinetic energy and it expands and becomes less dense. And so that is why we say hot air rises, okay? So, this continual cycle of, heating and cooling of the air in this room creates that current, and that's how a fireplace in one corner of the room is able to eventually heat an entire room, okay? And then the same thing occurs, if we were boiling water on the stove. The fire down here at the bottom of the pan is heating the pan, and then the water molecules are bumping into the pan, and they're actually gaining kinetic energy because of conduction, because they're touching the pan. But the water molecules themselves, as they heat up, the hotter molecules want to be up near the top, and so they're kind of moving up, and then those colder, more dense water molecules are flowing back down towards the heat source, and as they heat, they're going to rise. And so you see the creation of this current in this pan. And so it's the same thing that's occurring in the room, just in a liquid. Okay, so let's talk about radiation. This is thermal energy transfer by the emission of electromagnetic waves. And it says here on the slide that particles are not required for this type of energy transfer. And that's true in the sense that these particles are not transmitting this thermal energy via vibrations. But they are required in the sense that their electrons are going to be absorbing and emitting this radiation, or these electromagnetic waves. When an atom's electrons absorb electromagnetic radiation, they're absorbing energy, and so they're gaining energy, gaining kinetic energy, and if they're gaining kinetic energy, then they're going to have more thermal energy. Okay, so a good example of this would be the sun. There's a lot of space in between the sun and Earth, and so there's not very many particles there where energy transfer can take place. And so the energy that we get from the sun comes from radiation, comes from electromagnetic waves that are able to be transported over long distances without particles. All right, but once those waves hit Earth, then the atoms and particles that are here on Earth are going to be absorbing that electromagnetic radiation and converting it into other forms of energy. Thank you for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.